Coming up on Factory Made, how to put up a house without lifting a hammer. Then, how weaving a new carpet can turn industrial waste into good taste. And a little pen that goes where no pen has gone before. Over the last few years, a lot of houses have gone up, and they wouldn't have gone up quite as fast without this, the pneumatic nailer. A nailer doesn't just have to be strong, tough, and easy to handle. It has to be absolutely airtight. Which is why at Stanley Bostitch of Rhode Island, they take their leaks seriously. If any part is off by 1/1000th of an inch, the thickness of a human hair, the air pressure drops, and the nailer's power starts to fade. And of all those parts, the toughest kid on the block has to be the nose. In fact, it's got to be tougher than nails. A lot tougher. Nails shoot out of the nose with a driving power of 800 inch-pounds over and over again. To make a steel that's up to the job, Bostitch actually changes its molecular properties. First, trays of noses are baked for 8 hours at over 1200 degrees Fahrenheit. After that, it's straight into the deep freeze for 3 hours at 120 degrees below zero. The heating and rapid cooling packs the steel's molecules closer together, making the nose 20 times harder than when it started. Then, it's back in the oven again for another hour at 300 degrees. This entire process makes the outside of the nose nearly indestructible. Reinforced steel is great, but you wouldn't want to make a whole nailer out of it. It'd be too heavy. The tool has to be light enough so that a builder can use it all day long. So the outer shell is made of aluminum, a much lighter material, only about 1/3 as dense as steel. It gets the signature Bostitch color. Electrostatic sprayers, like those used on boats and cars, coat the parts with powder paint, and human workers apply the touch-ups. The charged powder particles are attracted to the aluminum to create a tighter seal, meaning no air leaks and a more efficient gun. A slow shuttle through a 350-degree oven for 15 minutes, and the powder melts and cures to form a rock-hard, durable shell. Then, a 10-foot drop, the ultimate test. But the casting emerges unscathed. But what would a nail gun be without its ammunition? Nails are made from coils of metal wire. A mechanical ram turns one end into a head, while a clipper gives the nail its point. The nail canister can store a coil of up to 300 nails. That's enough hardware to put up at least half the wallboard needed for an average-size room before reloading. Even this canister that holds the nails gets special treatment. It has to be strong yet lightweight like the entire nailer. Air hose connector? Check. Steel trigger? Check. Super hard nose? Check. Nail canister? check. The nailer is finished and weighs only about 8 pounds. But before it can be sent out into the cold, cruel world of home construction, the gun has to pass one final crucial test. It has to prove it can actually fire nails. U.S. mills produce more than 2 billion square yards of rug a year. Just about enough to carpet all of New York City twice. Unfortunately, every time someone wants a change of floor decor, the old rug goes into the trash. That's a lot of nylon pile in the junk pile. At the Interface Floor Factory in Troup County, Georgia, new nylon carpets are born from the remains of old ones. Recycling discarded materials makes the operation more green. The goal is to have the process be carbon neutral. Every year, 30 million pounds of cast-off carpet is recycled here, where it's separated into its useful parts: yarn and backing. This is a phaser gun, though this one is a little less dangerous than Mr. Spock's. It gauges the polymer content of the old rugs so workers can sort them accordingly. Remnants of like materials are fed into a separator machine, where the top fluffy part is shaved off, sorted, and sent to another factory to be spun into new spools of yarn. When the recycled yarn returns, packed into thousands of boxes, it's respun into spools of every conceivable color and is ready to take on a new life. For each design, a specific amount of yarn is wound onto a smaller spool. The reason for small spools is simple. Without the right prep, the loom would simply grind to a screeching halt every time the yarn supply ran out. But this pre-measured yarn will keep spooling until the order is finished. Workers load these new spools onto the creel. Yarn from this rack feeds the power loom, also known as the tufting machine. Nearly all the carpet made in the U.S. is tufted. Here's what happens. The power loom uses an army of sewing needles to insert loops of yarn into a sheet of backing. That's tufting. And slowly but surely, a carpet starts to take shape. Static cling isn't just a problem in clothes dryers. It can really foul up the carpet works too. So to cut down on static and tangles, each and every strand of yarn runs through a plastic tube before entering the tufting machine. As the spools unravel, an operator feeds a thin layer of polyester backing into the same machine. More than 1,000 sewing needles work at lightning speed to tuft the carpet onto this first layer of backing. Occasionally, it needs a human touch to tuft an area the power loom has missed. With a few quick stitches at the back, the front of the carpet looks flawless. Once it reaches the proper length, the operator cuts the giant roll loose. Now, all they have to do is stay out of its way. If you pulled out the yarn stitched into this 500 square yard roll of carpet, it would stretch nearly 13 miles. But there's no way polyester backing is going to survive foot traffic from an average American family. So once the roll is out of the tufting machine, this apparatus toughens it up considerably. It sprays a latex foam directly onto the original backing. The foam penetrates the yarn, reinforcing the bond between tuft and backing. Carpets have a few natural enemies. Dust mites love to pitch their tents in the warm, humid pile. And stains kind of undermine the whole aesthetic experience. One foam takes care of the mites. Another fights off coffee spills and spots little surprises. The carpet moves through a giant 450-degree oven about the length of a basketball court. Here, the new layer of backing can firmly set. Now, say hello to Cool Blue. Cool Blue is a system that helps make these carpets green. It makes thick vinyl backing for new carpets from the recycled backing of discarded carpets, and then attaches it to the tuft. Even its power source is recycled. That's where the landfill comes in. Landfills aren't pretty, and they also stink to high heaven. That's because they have bad gas. Rotting food, garden waste, and other organic substances all eventually produce methane, which is very efficient at punching holes in the ozone layer. But methane isn't all bad. It can also be compressed and burned to create a clean form of energy. Interface pipes in methane gas from the local landfill to power Cool Blue, recycling fuel that would otherwise heat up the atmosphere. And the company has one more trick up its sleeve, keeping wasted carpet out of the landfill in the first place. These gray pellets that Cool Blue eats up are made from recycled carpet materials, the backings from those old carpets that were separated from their yarn at the beginning of the process. Start with a hefty portion of these backings. Add a few scraps from the cutting room floor, and into the blender they go. Yum! After the shredder chops and melts all that post-industrial and consumer waste, it all comes out looking like this. They may look like hamster food, but these pellets actually feed Cool Blue. First, it sprinkles the pellets onto a conveyor belt, then rolls on a layer of fiberglass for extra strength, and then another layer of pellets. These layers are melted together in Cool Blue's 450-degree oven. Carpet meet backing. Backing, carpet. The two sides are heated once more to melt the backing onto the carpet and bake all the layers to perfection. When the carpet comes out of Cool Blue, it's almost finished. But Interface does one more thing to keep even more wasted carpet out of landfills. They cut all their carpets into tiles. One problem with carpets is that they wear unevenly and get stains. But with tiles, you don't have to replace the whole carpet, just the damaged tiles. Interface uses a small square of adhesive tape to link tiles together and hold them in place. It's an economical and practical alternative to messy carpet glue.
Well, these are carpet tiles that have been put together, stuck together at the corners with a little piece of releasable adhesive tape with a sticky side up so that it's connecting all the tiles laterally and letting gravity hold them on the floor. Now, the beauty of that is that it replaces glue everywhere. If those tiles were installed in the typical fashion, you would have a full spread of adhesive, an eighth of an inch thick, a real mess to deal with.
To become tiles, the carpet roll takes a trip through the cutting machine. The carpet is sliced into 19-inch squares, which then take a final trip on the conveyor belt to be sorted and packed in what they call pizza boxes, pepperoni not included. Now, they're ready for shipment from the garbage dump to the showroom, and maybe a floor near you. space. It's not so easy to get there. And once you're there, a lot can go wrong. Even writing with a ballpoint pen is impossible. In the average ballpoint pen, gravity forces ink from the cartridge into the ballpoint tip and onto the paper. But in a place with no gravity, the ink doesn't go anywhere. Which is why those of us who spend our lives on Earth can't write upside down either. Very frustrating. But in 1966, the Fisher Space Pen was born. It writes at any angle, including upside down. The Space Pen can handle temperatures of 250 degrees Fahrenheit and 30 below zero, which is handy if someone happens to be doing the crossword on the planet Mars. For good measure, this is a pen that can write underwater and on greasy surfaces, and it will last almost 3 times as long as a typical ballpoint pen, which makes it very popular even with people who aren't astronauts. Consider this. At the Fisher Pen Factory in Boulder City, Nevada, they churn out more than 1 million space pens every year. Their success is built on 2 key innovations: a high-pressure ink cartridge and the patented gooey ink that goes inside. The first step in making a space pen is to fashion the tips from a coil of steel wire. A machine straightens the wire and then cuts it into pen tips about 1/4 inch long. It spits them out at a rate of 25 a minute. The tips are ejected in an oil bath that also keeps the machines from overheating. Then, these drills dig a channel in each tip. These are how the ink will flow to the ballpoint. The next step is to shape the end of the tip, where the pen's ballpoint will sit. That's what this machine, called the Albee, does. They say the pen is mightier than the sword, but this pen has something in common with a more modern-day weapon. The ballpoints are made out of tungsten carbide, the same metal used in armor-piercing bullets. It's twice as hard as steel. The Albee hammers a ball into the end of each tip. Then it heats and stretches the tip up around the edges of the ball to hold it in place. Blow the fit, and under high pressure, the ink will ooze right out of the pen and onto your nice, clean spacesuit. So far, this pen is manufactured pretty much like any ballpoint pen. But here's where any similarities stop. This is a space pen. It needs some space ink. Normal ballpoint ink is thin, which is suitable for normal ballpoint pens. But the space pen depends on a highly pressurized cartridge, which would create leaks if conventional ink were used. Space pen ink has the consistency of soft taffy, which raises a perplexing question. How can thick goo like this flow onto a sheet of paper? For the same reason toothpaste can be squeezed out of a tube but stay pretty solid on the brush. This ink is what's known as a thixotropic substance. At rest, it's a thick, dense gel. But under pressure, the ink turns into a spreadable fluid. To get the ink into the pen, hollow brass cartridges roll onto the assembly line. Ballpoint tips seal off one end. A machine then injects exactly 1.7 grams of ink. A sliding ball goes in next. The simulated gravity comes from this squirt of nitrogen and oxygen gas, which exerts about 35 pounds of pressure per square inch, about the same as an average car tire. As the pen writes, the pressure on the ball will force the ink evenly down the chamber to the point. Now, to seal the cartridge. A coating of glue goes in, followed by a brass plug. This keeps the ink from leaking out the back of the pen or evaporating. A regular ballpoint cartridge is open on the end, so the ink can dry out. But a space pen cartridge can write for more than 2 miles straight, so it will still be writing long after the average person runs out of things to say. With the inner workings now complete, workers assemble the outside of the pen. Fisher's most popular space pen model is called the Bullet Pen, and you can see why. Workers slip in the cartridges, pop on the bottom casings, screw them together, and top them off with tightly fitting caps. A quick test drive, and these pens are ready for liftoff. Whether they're destined for the kitchen counter or a trip to the moon, it's clear the Fisher Space Pen has the right stuff.